everyone, my name is Jessica Perez, and today I will be explaining to you Chapter 2, Problem 93 from the textbook. So the question states, if force B equals 560 newtons and force C equals 700 newtons, determine the magnitude and the coordinate direction angles of the resultant force acting on the flagpole. So our first step is to identify the givens, which would be the force of B equals 560 newtons and force C equals 700 newtons. Afterwards, we can examine our picture and see that the height of the flagpole equals 6 meters. In addition, we also see that point B is negative y direction 3 and positive x direction 2 meters. And for point C, it is positive y direction 2 and positive x direction 3. So the second step would be to figure out what we are going to find, and in this case it would be the magnitude and the coordinate angles of the resultant force acting on the flagpole. Step 3 would be to make assumptions, and I assume that in order to find the force of B and C, one must determine the unit vectors of C and B as well. And that leads us to step 4, which is to make a plan. So step 1 would be to find the unit vectors of C and B by setting up U of B equal to RB over RB. Then step 2 would be to use the unit vectors and the force to determine the force vectors of force B and force C. Step 3 would be to finally solve for the resultant force by adding FB and C together. And finally, step 4 would be to calculate the magnitude by squaring each component and taking the square root. And then to find the direction, you do the cosine of each component. So then that takes us to step 5, which is to make a free body diagram. And we see that force of B to point B on the from the flagpole is what we're solving for, in addition as point C, the force created. And I added the height of the flagpole, which is 6 meters, and also reinforced the distance from the axes for both points. This then takes us to step 6, which is to find the solution of the problem. So we start by finding the unit vector of point B, and we have to we use the magnitude at the bottom in the denominator, which would be the square root of 49, which also equals 7, and then we do the top with subtraction, and that gives us 2 over 7i minus 3 over 7j minus 6 over 7k for unit vector B. And then for unit vector C, we do the same thing, and in that case we get 3 over 7i plus 2 over 7j minus 6 over 7k. Then we are able to solve for the force, so we multiply by unit vector B times the force of B, and that gives us 160i minus 240j minus 480k newtons. Then we do the same thing for force C, which would be 700 times 3 over 7i plus 2 over 7j minus 6 over 7k, which gives us 300i plus 200j minus 600k newtons. Then to solve for the resultant force, we just add those two, which gives us the final answer of 460i minus 40j minus 1080k newtons. And then to solve for the magnitude, we just get each of those components, square them, and take the square root, which results us with 1,174.56 newtons, or 1.17 kilonewtons. Then to find the directions of the resultant force for each component, you take the inverse cosine of each, which would be the inverse cosine of 460 over the magnitude, which results x to be 67 degrees, y to be 92 degrees, and z to equal 157 degrees. And that is that. So thank you for following along, and have a good day.